Alright, so a couple practice problems dealing with our causation and our correlation. So first off, we have a local school district. 10 students were surveyed here, and we have recorded the number of musical instruments that that student plays and their math grade. Okay, so we're going to use our calculator to determine the line of best fit and the correlation coefficient of the given data. So I'm going to go into my calculator, I'm going to turn it on, I'm going to go to Stat, Edit, and I'm going to input my values here. And so my x values are my number of instruments, so I have 0, 0, 0, 1, 1, 1, 1, 2, 2, 3. And then my math grades are my y values, so 76, 64, 84, 79, 84, 81, 92, 93, 84, and 98. Okay. I'm going to go back to Stat now, over to Calculate, and I'm going to do 4 for that linear regression right there. L1 was my x value, L2 was my y value, so I'm going to go ahead and calculate here. And I come up with these values. So it's asked for the line of best fit. So I'm going to have y is equal to ax, and I'm just going to round to the nearest hundredth. That's what my direction is telling me to. So 7.36 x plus my b value, 75.40. Okay, that's my line of best fit. I'm also asked to find the correlation coefficient. So R is going to be equal to 0.76. All right, that's my R value. I'm rounding again to that hundredths place. Now, the question, part B, asked me to describe the correlation, if any, between the variables. Okay, so we are going to describe that correlation. So my R value, it's positive, so I know that it's going to be a positive correlation. And I'm going to look at that number and decide if it's closer to 0 or closer to 1. And in this case, it is closer to 1, so this is going to be a strong positive correlation. Okay, now, the third part of this question is an opinion question. Is it likely, doubtful, or unclear that this correlation is a result of causation? So, a couple things you have to consider on this. Is the number of instruments that a student plays the cause of their higher math grade? So the more instruments they play, does that cause them to have a higher math grade? And then the second part of the question is, does having a higher math grade cause them to play more instruments? And it's unclear because there's more information that's needed. There's more studies that need to be done on a question like this, but you could see where there might be some correlation there. There's math involved in instruments and in playing music and reading music, and so you could go both ways on this. The number of instruments they play does not directly make their math grade higher, but the mathematics that come from that and the learning might make them a stronger math student. So so this is an opinion question that you could go both directions on. You can be very literal with it. You can kind of read into it a little bit more, and as long as you show evidence of your opinion, that's okay. It's going to be your opinion on this. As far as if I'm going literal with this, the number of instruments they play does not literally make them have a higher math grade, and their higher math grade does not make them play more instruments. So probably not a causation there, but there's definitely some more studying to be done with a question like that. Okay. Now, looking at number 3. You have a local coffee shop, ask 20 regular customers to share the number of ounces of coffee that they drink per day and their height for research purposes. So the results of the survey are recorded in the scatter plot below. So here we have a scatter plot with all of this data. And so just by looking at it, and we're looking for causation or correlation, there doesn't appear to be a correlation of any kind. There's no positive movement, no negative movement. It's just kind of scattered every direction. And so I would call this a no correlation. And in that case, what would my value of R be closest to? And so it is estimated to be approximately 0, because there is no correlation there between them. Okay, so that would be my estimate for this problem. Now, part B says, in terms of correlation and causation, what does this estimated value of R mean? So in terms of causation, if there is no correlation, then there can't be a causation. So there's no evidence that the amount of coffee that they drink affects their height, or that their height is affected by the number of ounces of coffee that they drink. So there appears to be no causation along with no correlation in a question like this.